Guys, so we're going to go ahead and just dive right into our first lesson here. What I'm going to do first actually in this video is just go over our calendar for upcoming lessons so you have an idea of what's going to be happening. Here we have our calendar for fourth quarter. The lesson we're going to be working on today is going to be for a new unit. It's going to be Unit H. And this is going to be the first lesson. It's on finite and infinite sequences, recursive and explicit formulas. So it's definitely something new and totally a departure from all the trig stuff that we've been doing for the last couple months. So hopefully that's good news for you because I know trig was kind of difficult. So we're going to go ahead and get started. So I'm going to pull up the notes on the screen here, and then I'm actually going to be annotating this on my Chromebook, so I won't be looking at the camera a whole lot, but I'm like looking this way at my Chromebook so I can write and see what I'm writing. Part of what I'm going to be grading you guys on is actually going to be taking the notes that I'm using in the video, that I'm demonstrating in the videos for you. So it's going to be extremely important when you're turning these in that you actually do fill out the top of it with your name and the date and all that. It'll just help me keep better track of what's being submitted. So we're going to go ahead and fill that in. I've got my pen tool here. And we're just going to put my name at the top. Look at that. Lovely. Okay, and today's date, this is actually Tuesday still, so I'm going to go ahead and put this here on 3/31. This is going to be Unit H, and this is Topic 1 or Lesson 1. That's all you really have to write. You don't need to write out the whole name of the section. I also want you to put your class period here. So I'm just going to put period number, and then you guys will know what to do, okay? So let's go ahead and get started. So first thing we're going to talk about is what is a sequence. So a sequence is when you have a set of numbers. Ooh, it's not writing for some reason. Hold on. There we go. So a sequence is when you have a set of numbers that have a particular, like a pattern to them or something that you can figure out, like it's changing by the same amount every time, or they're in a particular order. So a set of numbers that has a particular order or a pattern. Each number in a sequence is called a term. So that's important for us to define here because we're going to be using the word term a lot to describe. You're going to be asked to find a certain number term in a sequence, and so on and so forth. So each number is called a term. Okay, so the first thing we're going to look at is what's the difference between a finite and an infinite sequence. So a finite sequence has like a limited number of terms in its set, so it starts and stops at a certain point. Infinite, obviously, you know, the definition of infinite is that it goes on forever. So an infinite sequence doesn't have a stopping point, and that does change the type of problem that you're going to be looking at. So let's go ahead and define these. I'm going to change the pen color too. So this is a set with a specific okay, so an example of something that would be a finite set. We use the braces, which I'm terrible at drawing, to define what a set of something is. So we're going to use, we're just going to make something up like 1, 3, 5, 7, 9, and it stops here, meaning this sequence or this set of numbers literally contains these 5 terms and nothing else. Nothing before 1, nothing between any of the terms, and nothing after 9. And you'll see the difference with infinite, the way that we use that notation in a moment. So an infinite sequence is when you have a set with an unlimited number of terms. It doesn't end. And an example of what an infinite sequence would look like if you wrote it in this notation with the braces would be, let's say you have a sequence that starts out like 1, and then 3, 5, 7, 9. And then you have a comma, and then you have an ellipsis, or these 3 dots here. And the 3 dots, that signifies that there's more terms that come after that. They're just not written here. It's kind of like shorthand, so that you can tell the difference between when it's finite, or if it continues on, it keeps going. There's more things coming after that. So another piece of, I guess, terminology that you need to know about is how we use term notation, or how we use like a subscript in order to explain what number term we're looking at. So the first term in any sequence, we're going to call that A sub 1. The 1 is in subscript. It's underneath the A. It's not next to the A. Okay, so that's different than just writing A and then the number 1 next to it. This is A sub 1. It's the first term. I probably will just say like A1 or A2 or A3 instead of saying the word sub. So just pay attention to that terminology. Okay. Let's see. Each subsequent term is denoted by A sub n, or A sub n, where the n is the that's going to be the term number that's in the sequence. So you're going to see lots of problems that have like A sub n minus 1. So that means you're taking the number term that you're looking at, but the one before it. You're looking at the term that's right before that, because it's not the third term anymore. It's the 3 minus 1 term, which would be the second term, and the second term comes before the third term, if that makes sense. So let's go do an example. So if you're given the sequence, this is an infinite sequence of 1, 5, 9, 13, 17, identify the following term values. So the first term in this sequence is going to be 1. And then the fourth term would be 13. I'm literally just looking at what was given to me and counting 1, 2, 3, 4 terms over. That would be 13. Next thing they're asking for is what the 9th term is. So the 9th term is not given to you, but you have enough information to predict what the common difference is between these numbers. So the difference between 1 and 5 is you're adding 4. The difference between 5 and 9 is you're adding 4. 9 and 13, 4. 13 and 17 is 4. So the pattern here, or the common difference between all these terms, is that you're adding 4 every time. So you can fill out the rest of this sequence, just list out a bunch of the terms, so you can figure out what the 9th and the 12th terms are. This one went up to 5, so the 6th term in this sequence is going to be 21, because 17 plus 4 is 21. And then 25, 29, 33, 37, 41, and then 45. I don't know if I did enough. Let's count them. So 5, 6, 7, 8, 9, 10, 11. Yeah, that's 12. That's 12 terms in the sequence. So now you can very easily pick out what's the 9th term and what's the 12th term. Later on, we're going to be using formulas to do that, but this is like the most basic way. So the 12th term is 45. That's the one I just counted up to. And then 11, 10, 9. So the 9th term is 33. Okay, so that's everything we've got so far for defining some things about sequences. Let's go ahead and move on to the next section of the notes. So mine, you'll see on my screen, I had to break this up so that it would be large enough to write on and easy to see. Yours will be just one continuous page. So I'm just going to flip to the next screen here. The next thing we're going to be looking at is defining a sequence as a function. So the reason that this is listed here is because each each term in a sequence, like the first term, the second term, the third term, is paired with exactly one output. So the first term is 1, the second term is 3, the third term is 5. That's just an example. So because there is exactly one output for every input, a sequence is actually a function. So the domain of that function is going to be the set of, let's see, the term numbers, and the range or the outputs, the y's, that's going to be the set of the actual term values. And in an infinite set, the domain is going to be, so the numbers that you could possibly have for the input, or the x value, in this case the n value, that would be all natural numbers. So remember, natural numbers doesn't include negatives. So in a sequence, in a function which is a sequence, you won't have any inputs that are like -1, -2, -3. It's only going to go from 0 up until basically infinity, because it's an infinite. This gets an infinite set. So. Okay, so next thing we're looking at is something called a recursive formula. It's a big fancy math term. When something is recursive, it means that it is basically it's created by itself, and that might be a pretty abstract concept to think about. But all we're really saying in terms of sequences is that if you're using a recursive formula, it means that you're going to be given a term or several terms that are in the sequence, and you're going to be asked to create the formula so that you can find any other term that's in that sequence. So let's go ahead and let's define this. So a recursive formula is a rule. It's a rule where you are given one or more previous terms. And you're going to use that to find the next. So there's something called a Fibonacci sequence. That's like a special case of a sequence. And the Fibonacci sequence is an infinite sequence, and the first couple of terms of that are 0, 1, 1. And then we have 2, 3, 5, 8. Let's see, what would be next? 8 and 5 is 13, and then 13 and 8 would be 21, and then so on and so on and so on. And I put my little dots there to show that it continues. So in the sequence that you're being shown here in the Fibonacci sequence, the first term is 0, the second term is 1, and then for every term that comes after that, what's happening is the previous two terms are being added in order to find that next term. So the formula that you would use for a Fibonacci sequence would be, to find any term in the sequence, you're going to be taking the term before it. Oop, hold on a second, because I wrote that a little too high. You're going to be taking the term before that one, and the term before that one, and adding them together. Okay, so let's kind of explore what that looks like and what we're talking about. So let's say, for example, I was looking for the third term in a Fibonacci sequence. This is the rule for it. And the third term, we already know it's 1 because the whole thing is listed there, but the third term would be found by adding, if you do a n minus 1 sub n minus 1, if n is 3 because you're looking for the third term, then you're going to take the a n minus 1 term, which would be 3 minus 1, which is 2. So that would be the second term, plus go 1 before that. So the second term plus the first term. We were already told that the first term and second term were 0 and 1, so just add 0 and 1 and you get the third term in the sequence. And that rule can be applied over and over and over again to find the rest of the numbers in the Fibonacci sequence. Let's do an example of some more recursive formulas. So we're being told in the first example here that the first term in our sequence is 14. And they actually gave us what the rule is also. The directions in this problem are telling us to just find the next 5 terms. So if the first term is 14, then I already have one. I'm sorry, I read the directions wrong. It actually says find the first 5 terms in the sequence. So I have the first term already because they told it to me. I need to find the second term, third term, fourth term, and fifth term. What I'm going to do with that is basically if this is n equals 1, the next term is going to be when n equals 2. So if n equals 2, let's just plug that into our rule here. That would mean that a sub 2 equals a sub 2 minus 1. Well, 2 minus 1 is 1. So that's going to be the first term, or a1, plus 9. So if we know the first term is 14, and we're going to take that 14 and add 9 to it, then that's going to give us 23, and that would make the next term 23. Okay, let's keep going with that. So basically what the rule is saying is that to find any term in this sequence, we're going to take the term right before it and add 9 to it. So that would mean that the third term would be the term before it. In this case, that would be 23. So the 23, and you add 9 to that, is going to give you what? 32, right? So the next term is 32. In this next term, the n is going to be 4. This is the fourth term of the sequence. And you find that by taking the term before it and adding 9. 9 and 2 is 11. 11 and 30 is 41. So the next term will be 41. And then I think we pretty much have the pattern by now. We're just adding 9 every time. So the next term in the sequence is going to be 50. And just so I can have this be looking complete, that's going to be the fifth term in the sequence. Okay. Now, from this point forward, basically the formulas just get, a little more complicated in terms of what you're solving for, but the procedure is pretty much the same. So let's go ahead and look at the next problem. The next problem, the first term we were given is 6. We're finding the next 4 terms in the sequence. So I'm going to put just some blank lines here. Okay, that's what we're filling in. And the rule we were given is that any term in the sequence is equal to 2 times the term before it, and then you subtract 5. So if we're looking at the second term, we're going to take the term before that, which is 6, and multiply that by 2, and then we're going to subtract 5 from our result. So 2 times 6 is 12, and 12 minus 5 is 7. The next term in this sequence is going to be 7. So you might be looking at this and saying, oh, this is easy, it's just off by 1 every time, or you're adding 1 every time. Don't be deceived by that. Try to find a couple of other terms first to make sure that you really have a solid understanding of what the pattern is that you're looking at. So let's look at the third term. The third term can be found by doubling the term before it and then subtracting 5. So 2 times 7 is 14, and 14 minus 5 is going to give me 9. Okay, so 9 will be my third term. Next term is going to be double the term before it, minus 5. So 9 times 2 is 18, and 18 minus 5 is 13. So it's not so easy as just saying, add 1 or add 2 every time. You literally have to either figure out what the rule is or use the one that they gave you in order to solve these problems. Okay, so our last term is going to be double the one before it, minus 5. So 13 times 2 is 26, and 26 minus 5 is going to give me 21. Okay. So if I flip this screen to the next part of the notes, you're going to see a couple more examples. I'm going to leave 3 and 4 for you guys to practice with. So if you would like, you can just go ahead and pause the video and attempt those problems right now. Let me just circle these so that I know that they were ones that you guys were doing. And I'm going to go ahead and move on to the next type of problem that you might get for this, which is going to be where you're given terms and you need to find, well, 2 things actually. You need to find what the rule is, and then you also need to tell what the next 3 terms in the sequence are. So there's a pretty specific way that we're going to go ahead and do that. And if you would like to, like I said, pause the video here, and then you can do 3 and 4, and then we'll go ahead and move on to 5 and 6, a different type of example. Okay, you guys, so I'm back, and I took a little moment there just to look at what was coming up next in these 2 examples for 5 and 6, where you're writing the rule for the sequence. I don't love these problems that they're giving you, because it's different from something like a sequence where there would be a common difference every time, or a common ratio, like a multiplication or division problem. There's lots of elements at play. It's not like a predictable, figuring out how we go from what the first term to the second term to the third term. You got to do a lot of like reverse engineering and kind of like playing around with the numbers to settle on what the actual rule is. So what we're going to go ahead and do for this is we're gonna skip them, and I'm gonna just, oh, that looks terrible. Let's not use that. Let me choose the right marker here to do this with. Let's see, maybe this will work. Okay, so we're going to just go ahead and we're going to skip these 2 problems, and we're just going to move on to the next part of the notes, which is about the explicit formulas. We're finding sequences using explicit formulas. So let's grab another color here and let's figure out what this is. An explicit formula is when is a rule. So it's a rule for a sequence. Oops. Well, let me switch to the next screen too. Sorry. It's a rule in a sequence where the nth term it's defined as a function of n. You don't need to know any of the terms in the sequence in order to find any of the other terms. So this is different from recursive, because in recursive you need to know something about the sequence already and what is in the set in order to go ahead and apply the rule. So let's do some examples of this. And actually, I'm going to actually jot that note on here so that we're on the same page. Previous terms not needed. Okay, so previous terms are not needed for this, and let's go ahead and do the first example. So the directions say find the first 5 terms of each sequence. The rule that you were given is that a sub n, which is any term, so any term in this sequence, can be found by doing this formula, which is 7 times the quantity n minus 3. Now remember, the n that's being used here is what number term you're trying to find in the sequence. So for example, if we're trying to find the first 5 terms, we're going to be looking for, let me just get my marker up, we're going to be looking for A1, A2, A3, A4, and A5. And let's just use the first term as our example. If we're looking for the first term, that means n is 1. So a sub 1 is going to be 7, but instead of n, we're going to use the number 1. So 1 minus 3. And then let's just compute that and find out what that's equal to. So in the parentheses was what you do first. 1 minus 3 is negative 2. And 7 times negative 2 is negative 14. So that's the first term of this sequence. Okay. Notice how this problem is different from the ones we've been doing because you don't have any other terms and you don't need any of the other terms in order to find anything else in the sequence. Okay. Let's find, I'm just going to skip and do the fifth term. You can find all the ones in between. It's really not that hard. You're just plugging in. So let's say we're finding the fifth term of the sequence. That's going to be the same function, but instead of n, here's the n. Instead of n, we're going to be doing 5 because n is 5 in this case. So 5 minus 3. And 5 minus 3 is 2, and 2 times 7 is 14 positive. So there's going to be some other numbers in between that, but it goes, this sequence is going to start at negative 14 and then work its way up to 14 and beyond. It's going to keep going. Okay. Let's do another example. We're going to do number 8 here. And in number 8, you can see that the rule we were given is that a sub n, or any term, so any term of the sequence can be found by doing the function 1/3 to the power of n plus 1. So whatever term you're looking for, plus 1, that's the exponent. And then you're going to take 1/3 and raise it to that power. So let's say we're going to do, let's just find the third term. I know these directions say find the first 5 terms, but I'm going to run out of space if I try and do all those. So I'm just going to do like 1 or 2 terms, okay? So let's try and find the third term in the sequence. That would be a sub 3 or a3. So the n is going to be 3 in this case. So that's going to be 1/3. And that's to the power of 3 plus 1. 3 plus 1 is going to give you 4. So that would be 1/3, the fraction to the power of 4. Remember, our rules for exponents dictate that when you have a quantity raised to a power, the exponent here actually applies to both the numerator and the denominator of the fraction. So this is going to become 1 to the 4th power over 3 to the 4th power. 1 to any power is just going to be 1 because it's 1 times itself that many times. And 3 to the 4th power, let's use the hand trick. So 3 times 3 is 9, times 3 is 27, and then times 3 again is going to give us 81. So that would be the 4th power. So 3 to the 4th power is 81. Okay, that would be the third term in this sequence. If you calculated another one, you'd probably end up still with some type of fraction. In fact, I think your very first term of this sequence is going to be 1/9. So what I'm going to do for this is just leave the rest of these problems for you to do in your notes as classwork. And then that's actually going to be it for this lesson. There's a little bit more in the notes that I posted for you. And I'm going to annotate them separately so that you can see the ones that we skipped and the ones that I'm expecting you to complete. For this lesson, your assignment to follow up for this is going to be twofold. So first, I'm going to be grading to see that you actually took the notes that we did together on this video. And then there were, I think, 6 problems altogether. 1, 2, 3, 4. If I flip back a page or 2, yeah, numbers 3 and 4 were ones that I asked you to do also. So that's going to be 6 example problems I want you to work on. I'm going to be checking to see that you completed those as sort of like your classwork for this, and that's also going to be a separate grade just from me verifying that you did the notes. So 2 grades, 1 worksheet, and then let's see, this lesson is for Wednesday, so on Friday's lesson we'll be moving into the next section, and there'll be more work that goes along with that. Okay. Hope this lesson was handy for you. If you need additional help on this, please feel free to send me an email or a remind or something like that, or even comment on this in Google Classroom or on the YouTube channel. And you can let me know what you need. I can refer you to additional resources, other videos that explain these problems, maybe in a slightly different way or some way that you'll understand it better. Or, of course, I am available to meet with you using Google Meets. We can do a live session, video chat, and we can just kind of go over some of these problems and clarify your understanding. Okay? Thank you, guys, and see you in the next lesson.